Good morning children, welcome back. In previous class we have completed introduction about refraction. So once again we will remind what is refraction. See, when light travels from one medium to another medium, there is a change in speed of light. When there is a change in speed of light, there is a change in direction. So that change in direction results the light ray to bend and travel. That is simply refraction. Okay, this is an important phenomena of light. Okay, so after completing that introduction about refraction, we have defined two mediums. What are they? Rarer and denser. What is meant by denser? In which medium the speed of light decreases, that medium is taken as a denser medium. That means that medium is optically denser. In which medium the speed of light is more, that is called rarer medium. Okay, so every medium compared to vacuum denser medium. That means what is the speed of light in vacuum? 3 into 10 power 8 meters per second. So compared to air or vacuum medium, every other medium should be taken as denser medium. But with what speed the light travels in those mediums? To know about it, we have to define a physical constant, a new physical constant, that is nothing but a refractive index. Okay, let us see. Generally the speed of light in vacuum is 3 into 10 power 8 meters per second. In clarity, 3 into 10 power 10 centimeters per second in centimeters. Or to understood easily, you can convert it into kilometers. 3 lakhs kilometers per second. That means in 1 second light travels 3 lakhs kilometers. Okay, in vacuum or air. So that is the speed of light. Till now no other object is there to travel with that much of speed. Okay, now we have to find out the speed of light in other mediums. How to find out? Let us say the speed of light in certain medium is v. Okay, now we are going to define. How to define? We have to compare with the constant value. Comparison means we have to see the ratio. That is the speed of light in vacuum C by the speed of light in medium, that is denoted by V. This is nothing but absolute refractive index. Absolute refractive index. What is that? Absolute refractive index. That is given by C by V, and it is denoted by N. It is denoted by N. Actually, it is denoted by mu. This is called mu. You can also denote it as by using N. So this is absolute refractive index given by C by V. That means we are comparing the speed of light in particular medium with a constant value C. So we can get the speed. But what is the main purpose of this refractive index? What it knows? That means simply refractive index tells with how much fast or how much slow the light travels in a medium. With how much fast or how much slow the light travels in a medium. Okay, clear? So by knowing the refractive index of any medium, you can find out the speed of the light in that medium. For that we have different types of mediums and their refractive indices values. See here, the air having refractive index of 1.0003. Sir, what about the units? Did you observe? We are taking the ratio of the same type of physical quantities. C is nothing but speed of light in vacuum. What are its units? Meters per second. And V is nothing but speed only. What are the units of speed? Meters per second. So both are gets cancelled and we will get 0. That's why refractive index has no units. So this is about the refractive index, and tells with how much fast and how much slow the light travels in a medium. Okay, and important thing is the refractive index depends on two important factors. What are they? Factors. First one is nature of the material. What is that? Nature of the material. Nature of the material. Second one is wavelength. Wavelength of light used. So the refractive index depends on nature of the material. That means with which material the medium is made. And second one is wavelength. Wavelength means the horizontal distance, the distance between two crusts or two troughs is in the form of wave. Okay, so based on this the refractive index depends, and refractive index tells simply with how much fast or how much slow it will travel. Okay, sir, what about we are considering the vacuum as a constant. Then what about if light travels from one medium to another medium except vacuum? About that we are going to see in the next class.